So, welcome everybody. My name is Attila Farkas, and today I would like to present first of all, the HUN-REN Cloud, and then our new inventions or our new services to support the AI4Science program. I am in a easy position currently because in the previous talks and in yesterday, there was some mentions about the HUN-REN Cloud and also about the Gen AI for Science service. And in this presentation, I would like to present the other side. Currently, we heard about how the service works, how the users can use the service. And in this presentation, I want to talk about how the service look like, how much resources do I providing for it, and so on and so on. But first of all, what is the AI for Science program? In the previous presentation, we also heard about what is this program, but the main part of it is the AI Ambassadors program, as we heard in the previous presentation. Marcel Vanhoff is this ambassador, and this ambassador network's main goal is to support the researchers in the HUN-REN network to use different kind of AI technologies. And another important tool is the available AI technologies and the provided resources for these AI technologies. And one of the main resources for the whole AI4Science program is the HUN-REN Cloud. HUN-REN Cloud is originated and the first version of the HUN-REN Cloud was the MTA Cloud, which is created in 2016. And after that, the second iteration was the EAKH Cloud in 2020. And since the rebranding and renaming of the whole research network, we also renamed the cloud to the HUN-REN Cloud, and this is the current status of this infrastructure. The main goal of this infrastructure to provide computational resources for the whole Hungarian research network and also for the Hungarian universities, and we have some international connections as well. This cloud is a federated solution. One of the parts is located in the HUN-REN Staki, and the other part is located in the HUN-REN Wigner data center. And both of these sites has their own advantages, disadvantages, and own features. I will talk about a little bit later. And in this figure, you can see that the usage of this cloud and the project numbers is just increasing through the days, through the years. And in the last year, we achieved nearly 400 projects which is registered and actively used this research infrastructure. And this project requests can also provide an insight about how much resources do we need to support these kind of activities. And because of the high usage of AI technologies, we also want to provide AI tools and different resources which can be used for AI-based research. About the capacity and active usage of the cloud, in the MTA cloud, we had a smaller cloud deployment, and in those days, in 2060s, 80s, we didn't focus too much on GPU resources. On those days, we mainly focused on create a cloud, create a platform to support the Hungarian research activities. But when we extended this MTA cloud and created a new version of it, then we focused on the GPU resources as well. As you can see here, we also increased our CPU and also our memory capacity as well. The memory capacity nearly 10 times higher than in the previous iteration of this cloud. And in the GPU side, because this is the most interesting part in this event, we extended our GPUs with 40 NVIDIA Tesla V100 and 40 A100. The V100 cards are located in the Staki side of the cloud, and the A100 cards are located in the Wigner side of the cloud. And also in the Staki side, we have Intel-based. On the Wigner side, we have AMD-based processors as well. So the two sides are a little bit different from each other, but it's also a nice opportunity to us to provide the best hardware components which can be used for the requested projects. And in this figure, you can see the current activities and the current our user base. Mainly, we supported through the years more than 30 different organizations. We had more than 500 different project members. And with the usage of the cloud, we only ask one thing back is when the researcher publication their results, then we ask those researchers to cite one of our papers, and with that we can monitor how this infrastructure is used for different kind of research activities. You can see that with the HUN-REN Cloud support, more than 300 research publication is created through the years since the MTL Cloud is created back in 2016. And we are nearly reached the 400 projects currently. We had also online events. Most of it are presenting how you can use the cloud. Most of it are just presenting our new services or new opportunities on the cloud. I am also one of the presenters on these events as well, and these events also have a higher number of attendees. Okay, but this amount of research and made the GPU cards look like enough in 2020 and 2021 when we created and when we announced that the cloud is publicly available. But nowadays, this amount of GPU cards and mainly the type of this GPU cards is not enough for every kind of mainly AI-based research activities. And at the end of the last year, we reached that status that we cannot provide more resources for our users because we ran out the available GPU resources mainly. And currently, we are also reaching the memory limits of our infrastructure as well. But the GPUs was the first one which we ran out, and we cannot serve more and more projects which are arrived at our project request page. Therefore, we had to create a new GPU allocation system. The main idea with this GPU allocation system is mainly works as the same as was the project allocation was designed in the first years of the cloud. But when we have to provide, when we don't have enough resources, then we somehow have to manage this situation. And why we are in this situation? Mainly because of the AI4Science program, more and more AI activities are requesting resources from us. Therefore, we had to manage these increased resources. And we also planning to upgrade our cloud and add new resources and more GPU and CPU resources into this infrastructure, but is a little bit delayed as our original plans. But we do our best to extend our currently available resources. And we also created some centralized services, and I also will present these services just to speed up the GPU utilization. And how we are planned to answer this increased GPU request, we created different kind of new services. The original service was the infrastructure as a service mode, when the researcher just asked for resources from our cloud, and then we review that project request and then provide that research for the researchers, and then the researcher can just create virtual machines and use those researches. But this type of access mode is not so dynamic. If the researcher asks for that amount of resources for 1 year or 2 years, then those GPU cards or CPU resources are allocated for that amount of time for that researcher. Therefore, we created different kind of projects. We also created this 1-year projects, which is designed for mainly service providers and umbrella kind of projects. I will talk about it later. But the other invention is that we reconfigured our resource allocation process with these 3 months projects. And with that, we try to speed up that resource allocation. And our users a little bit has more activity, needed more activity to get these resources. But with these 3 months, we can clean up the unused resources and provide that for new research projects. So with that, we can speed up the utilization of the unused resources inside the workload. And we also introduce different platforms, service solutions like the Slurm Job Manager and the Gen AI for Science platform, which previously presented before the break, but I also will talk about these different access mode for the cloud, because previously we didn't provide the platform as service solutions. We just provided the bare resources and help the users to use these resources. But with these software solutions, the researchers can easily access different kind of functionalities which is provided by our infrastructure. So in this new GPU allocation system, we planned this system to work similar as the previous one. So if we have enough resources to serve the requests, then there isn't any change. Just the users have to request the resources per 3 months. And if we can, we will provide those kind of resources. But if we run out of the resource, then we will switch uh, to a fairly competition type of resource allocation. When we get these project requests from our users, and then we will just check them, and somehow we create an order that which kind of research, which kind of projects can be or cannot be supported on that specific period. So with that, we are managing this competition fairly, because if we don't have enough resources at that point, then we will recheck every resource request per a 3 months basis. Therefore, a new project doesn't have to wait years to free resources. We can provide those resources in a more faster way, and the competitive projects proposals will be assessed on the basis of uniform criteria, mainly scientific metrics, impact, and the resource request, and the type of the resource usage will be assessed, and based on that we will decide what kind of project can be or cannot be supported in this allocation procedure. And we are mainly focusing on the GPU resources. Therefore, we are creating a GPU allocation form which have to be provided by the user during our project request mechanism. And in this form, the user has to state that what kind of softwares they wanted to use, what will be the expected research result from their activities. And based on that, we can categorize that which research can be or cannot be supported on that specific period. Yes, currently it is available in a Hungarian format. We are doing our best to translate everything to English as well, but our main users are from Hungary. Therefore, we are mainly focusing on Hungarian version of the website. Okay, but we also created different kind of special projects because we've seen in the previous activities that we have different kind of users. Therefore, we wanted to serve them as well. The first version is the service provider project. It is an important criteria here that the HUN-REN Cloud is a kind of a best effort service, so we cannot say any kind of SLA, any kind of SLA percentage cannot be provided, because this workload is developed and designed by researchers to researchers. So we cannot say that it will be available at all time. Technically, based on our monitoring results, we have a pretty high availability, but we cannot guarantee that we can provide this service at any time on the week. And this service kind of projects is like the AI4Science, which is created by us, but also in the previous months, the Hungarian language model, the PULI, also migrated into the cloud. And this PULI project is our first kind of third-party projects on the cloud, which is not designed by us, but one of my users are requested those resources. And we also created this umbrella kind of projects which aim to provide resources for research institutes and universities, because we also seen that from our user base that from several universities, several different small projects are requested. If the university will provide us that they can request more resources from us, but in this case, the university have to manage that requested resources with this type of service. And with this type of project, the university can get more resources, but they have to manage that accessible resources on their own house. And we also created this advanced project. With this advanced project, the user needs to provide some kind of proof that they can use the resources. The idea behind that we've seen in some cases our users are requested the resources in the previous resource allocation format, but they didn't use those resources, and is sometimes the reason behind it that they cannot use that amount of resource what they requested. Because of that, we want to avoid this situation. Therefore, we created some kind of a preparatory projects. In these preparatory projects, we will provide smaller amount of resources, but if the research request he can provide some proof that they has previous experience with the HUN-REN Cloud or other kind of cloud systems, then we can easily provide that amount of resource what they accessed for. This was a nice idea, but in the first period of research request, everybody get the advanced project because everybody already used our system, so they know how they can move forward. Okay, and the important dates with this new allocation system is that we designed the 3 months project periods. We just divided the year into 4 different period, and the application deadlines can be seen here, and the next one will be on the next Saturday in May 31. So if you have already a project or you want to get resources from us, then please don't forget about these deadlines. And after the application deadlines, there's an evaluation period. This is a 2-week period when we check every sent request and assess them, and based on that we will create an order that which project can be or cannot be served at the current resource usages. The previous one was in March. That was the first evaluation period, and technically we can serve every request which we received during that period. Hopefully it will be true for the upcoming ones during the year. And there is also a preparation or closing periods when we provide 2 weeks period for a closing project to migrate their data from our cloud, and we also provide some time for the new projects to prepare their infrastructure, to prepare their execution environment. So that was the first period, which will be closing soon. So we started this new system in this year at April 1. So this is the first period, and after that, and this is also an important part, that everybody who want to continue their research have to resubmit their research request, because if it doesn't get any kind of information about that, that project should be continued, then we will close that project and provide the resources for other requests. Also, these are the important dates. If you want to use our infrastructure, please don't forget about that, but also we will send out some reminders about these important deadlines. Okay, and what kind of different platform service solutions are we created for our users? We've seen in the research usage patterns that in the most case our researchers are using the GPU resources in a burstable format. What does it mean? That they are using the GPUs for several hours a day or for 1 week actively, then 2 or 4 or 3 weeks they just evaluating the results, and they are not using those GPU resources, but that resources are allocated to their project. Therefore, those will be unavailable resources for other projects. Therefore, we created a Slurm service which can mitigate these kind of problems, and this can speed up the resource allocation for our users. Slurm is an open source resource management and scheduling system which are providing job and batch scheduling, and this is an HPC system solution. So, for example, in the Commander HPC or nearly any kind of HPC in the world are based on Slurm or similar kind of resource management systems. So, if you have some experience with that, then our Slurm implementation works pretty similarly than different kind of HPC solutions. And that was designed, and that was our main goal, that in our cloud, obviously, we cannot provide that kind of an amount of resources which an HPC can. It is a smaller infrastructure. It has other advantages, but it's a smaller infrastructure. And we also wanted to create this service as a playground. If we can provide enough resources for that kind of simulations or model trainings, then our users can use our Slurm cluster. If we cannot provide enough resources, then the migration from our Slurm to, for example, Commodore can be easily done. We also had some nice results with this migration process. So if you are familiar with Commodore or any kind of HPC, then you will be the same you will see the same service at our infrastructure. And we designed this service based on our Slurm reference architecture, which means that this service can easily scale up and down based on the request, based on our result, based on our current utilization. And we also provide singularity containers for our users. And with these containers, the migration from our service for other kind of services can be easily done. We define different kind of partitions, just like in any other Slurm system. We specify this partition based on the GPU specific, based on our GPU specifications, because we have different kind of GPUs. Those will be served in different kind of partitions as well, with different queues. And the execution of the Slurm jobs are similar in just like any other HPC systems. The user have to prepare the job, then submit it to a Slurm controller. Then the Slurm controller will handle everything, the job scheduling and the job status checks. And after the successful run, the user can just access the results and migrate the results from our cluster. And then we recommend this service for short-term research requests when we also want to submit a model training and then not use the resources, then it will be an ideal choice for us. Or if we have longer batch-like computations, then this service will be much more feasible than just a virtual machine-based deployment. The registration process is integrated into our project registration method. So the user just has to check a box during the basic project request, and this Slurm will be just another kind of resources from the user point of view. After this registration process, we will provide the access for the service. The user just have to provide their SSH key. Then the user will has an access to our Slurm head node, and they can use this Slurm service. And in my last topic is a Gen AI4Science service, which is already presented today, but from the operation point of view, I just want to tell that the main idea behind this service to provide a chat service based on language language models, which is fully provided on the HUN-REN Cloud resources, which means that this is free for our users, and we don't, and the users don't have to pay for a subscription fee or any other kind of payment. And the data management is also guaranteed that the data won't leave the HUN-REN Cloud, and we won't share this data with other third-party services. And behind of this service, we have this Open Web UI implementation and different OLAMA nodes, and these OLAMA nodes will handle the GPU cards behind this service, and this web UI can provide the user-friendly interface and also multi-user support with user access management. And we also provide the Open API-based access, which means that not just the chat mode, but the API mode is also available. And this is how this service looks like. It's pretty similar as just the basic ChatGPT to any kind of these Gen AI services. The user can log in, then select from the drop-down list at which model they want to use, and then they can just chat with that model. This is how this chat works, pretty similar as any kind of Gen AI service. And we also provide REG, but that's another story and not for this presentation. The access request can be sent from our website. The user just has to provide their already provided information. Then one of my colleagues will provide the access for the service. Okay, use cases. We also integrated this with the Spot robot, which is also provided So we also have a support page, and this is my summary for this presentation. So we created this new GPU allocation system and different plasma services for our users on the HUN-REN Cloud. And thank you for your attention.
So thank you for this summary. Any questions, comments, the audience?
Hi, thanks for the introduction of the system. Well, surely the step to introduce the Slurm was necessary. I mean, this permanent allocation is not sustainable on the long term. But when I've used on HPC system, the Slurm system, foreign systems, I mean, this 24 hours limit of running jobs was kind of a pain in the neck. So is it more flexible in this system? Is it longer? Can it be adjusted? Or are there still hard limits on runtime of single job?
We currently have hard limits to how one job can be, but we can adjust it based on the user request. So currently we don't have too much users in this system because we just announced it at April, and we set that one job only can be run. The jobs will be stopped after 1 day. This is just an idea. If it won't be enough, then we can also extend it or shorten it. We will see how it will work, but we also searching the good way how we can provide the service.
Yeah. Any other question? Yes.
Thank you for the nice talk. I would like to ask a question about this Slurm architecture. So what kind of system or resources are available to the user? Meaning that if I have already a classical all-style project, but I would like to do a calculation on a big GPU for a short time, because I know that we will run for a short time, how can I access it? What will be the Python environment and things like that? What is the size of the GPU that I can access in Slurm? Thank you.
Okay, thank you for your question. We created this Slurm service based on our existing GPU cards. So currently in this system, you can get access for full-sized NVIDIA V100 and half and 4 size. And we will integrate it with the Wigner site, and then you can access for A100 with 40 gigs of memory. And for the Python environment, we are providing Singularity, which is similar to Docker. So if you have your application inside Docker with one command, you can build it as a Singularity container and just submit it into our Slurm cluster.
Okay, no more questions. So anyhow, you will have a hard time with an unruly gang of scientists questioning the resource allocation methods. But good luck. Thank you, and we call the next speaker.